Welcome to the module 4 fifth video. In this video, I am going to explain the Legendre equation. Legendre's differential equation. It is series solution of Legendre differential equation we are going to derive. The Legendre differential equation will be 1 minus x square into d square y by dx square minus 2x dy by dx plus n into n plus 1 y is equal to 0 is a Legendre differential equation. We call this as equation number 1, where p naught of x is 1 minus x square, that is the coefficient of d square y by dx square. And when we put x is equal to 0, this p naught of x will not be equals to 0. This implies x equal to 0 is an ordinary point. Now, we assume y is equal to summation ar x square x to the power of r be the solution of equation number 1. That is, when we are putting r is equal to 0 to infinity, it will be a naught plus a1x plus a2x square plus a3x cube and etc. That we will consider as the solution of this equation. When we differentiate this, dy by dx will be equal to summation ar into r x to the power of r minus 1, and second derivative of this will be d square y by dx square is equal to summation ar into r minus 1 x power r minus 2. Therefore, substituting this y dy by dx and d square y by dx square in the equation 1, the one implies 1 minus x square into summation r minus 1 x power r minus 2 minus 2x into summation r is equal to 0 to infinity r x minus x power r minus 1 plus n plus 1 into summation ar x to the power of r is equal to 0. By taking this 1 minus x square inside, it will reduce us to r minus 1 x to the power of r minus 2 minus summation r minus 1 x power 2 into x power r minus 2 minus 2 into summation ar into r into x power r minus 1 plus n plus 1. The third term remains the same, that is n plus 1 into summation ar x to the power of r is equal to 0. This is on substitution and simplification we get it. Now, summation r minus 1 x power r minus 2 minus summation r minus 1 into x to the power of r minus twice of summation r x power r plus n plus 1 summation ar into x to the power of r is equal to 0. Again, simplification of this leads to summation ar into r minus 1 x power r minus 2 minus summation ar into x power r. By taking common from the three terms, the last three terms, we get r minus 1 plus 2r minus n plus 1 is equal to 0. That is summation r minus 1 into x to the power of r minus 1 minus summation ar into x power r of r square minus r plus 2r minus n plus 1 is equal to 0. Summation r minus 1 into x power r minus 2 minus summation ar x power r into r square minus n plus 1 into n into n plus 1 plus r is equal to 0. Now let us equate the coefficient of x power r by taking r is equal to r plus 2 in the first term. We get ar plus 2 of r plus 2 into r plus 2 minus 1 minus ar into r square plus r minus of n plus 1 is equal to 0. That is ar plus 2 into r plus 2 into r plus 1 is equal to, that is taking it to the right hand side, ar into r square plus r minus of n plus 1. That is ar plus 2 will be equal to r square plus r minus of n plus 1 divided by r plus 1 into r plus 2 of ar. Let us call this as equation number 2. When we put r is equal to 0, this implies a2 is equal to minus of n plus 1 divided by 2 of a0. When we put r is equal to 1, a3 is equal to minus 1 plus 1 minus of n plus 1 divided by 2 into 3 of a1. Next, a3 will be 2 minus n square minus n divided by 6 of a1, that is minus of n squared plus n minus 2 divided by 6 into a1. So n squared plus n minus 2 will be written as n minus 1 and n plus 2. So we will write the a3 as minus of n minus 1 into n plus 2 divided by 6 of a1. Next, let us put r is equal to 2. Then a4 will be equal to 4 plus 2 minus n plus 1 divided by 3 into 4 into a2. That is 6 minus n plus 1 divided by 3 into 4 of a2. That is 6 minus n square minus n divided by 12 into minus n into n plus 1 divided by 2 of a0, which gives us minus of n square plus n minus 6 divided by 12 into minus n of n plus 1 divided by 2 of a0. That is a a4. All the even terms will be represented in terms of a0 and all the odd terms will be represented in terms of a1. So this will lead to minus of n minus 2 n plus 3 divided by 12 into minus n plus 1 divided by 2 of a0. That is by taking n square plus n minus 6 as n minus 2 into n plus 3. Therefore, a4 will be equal to n plus 1 n minus 2 n plus 3 of a0 divided by 24. Next, let us put r is equal to 3. We get a5 is equal to 9 plus 3 minus n plus 1 divided by 4 into 5 of a3. That is equal to 12 minus n square minus n divided by 20 into minus of, by replacing a3 value, minus of n minus 1 into n plus 2 divided by 6 of a1. That gives us minus of n square plus n minus 12 divided by 20 into minus of n minus 1 into n plus 2 divided by 6 into a1. That is n minus 3 into n plus 4 into n minus 1 into n plus 2 divided by 120 into a1. That is the a5. So in this way, y is equal to summation ar x to the power of r, that is on expansion a0 plus a1x plus a2x square plus a3x cube plus etc. That is a0 plus a1x minus, by replacing this a2 in terms of a0, we get minus of n plus 1 divided by 2 into a0 x square. Again, by replacing a3 in terms of a1, we get minus of n minus 1 into n plus 2 divided by 6 of a1 x cube. And a4 in terms of a0 will be n plus 1 n minus 2 n plus 3 divided by 24 of a0 x power 4 plus n minus 3 n plus 4 n minus 1 n plus 2 divided by 120 into a1 of x power 5. Now we need to group all the a0 terms and a1 terms. Then grouping all the a0 terms, we get a0 of 1 minus n plus 1 by 2 into x squared plus n plus 1, n minus 2, n plus 3 divided by 24 into x power 4 minus etc. Plus a1 into x minus n minus 1 into n plus 2 divided by 6 of x cube plus n minus 1, n plus 2, n minus 3, n plus 4 divided by 120 into x power 5 and so on. Let us call this as equation number 3. So, y is equal to a0 into y1x plus a1 into y2x, where y1 of x and y2 of x represents two infinite series in 3 and equation 4 represents the series solution of the Legendre differential equation. Thank you.